Hey guys, welcome to our vlog, and this is the group 11. And in our vlog for today, we will be showing you guys or explaining you guys how the Fibonacci works and how can it
Seen all around us and even outside the university.
We will show and explain the relationship to the Fibonacci sequence. Many students think mathematics only means solving equations, memorizing formulas, or answering difficult problems. But did you know that nature has been using mathematics long before humans discovered it? From the way flowers bloom to how leaves grow and even how fruits develop, hidden mathematical patterns can be found everywhere. Let's first understand what the Fibonacci sequence is. The Fibonacci sequence is a pattern of numbers where every number is obtained by adding the two previous numbers. The sequence begins with 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13. That is, this simple pattern continues infinitely.
But before we jump right into things or plans that has a possibility of being connected with the Fibonacci sequence, first we need to understand how it works.
Now that we've heard about the Fibonacci sequence, let's see if we can actually find it in nature. I am now here outside at the park because our first example is the Sampaguita, the national flower of the Philippines. Sampaguita is known for its small white flowers and pleasant fragrance It is often used in garlands during religious celebrations, graduations, and other special occasions. Aside from its crucial importance, Sampaguita also has a hidden mathematical pattern. Let's take a closer look. If we carefully count the petals, so this flower has 5 petals, and 5 is one of the Fibonacci numbers. But why is this important? Many flowers around the world naturally develop petal numbers that belong to the Fibonacci sequence. According to our reference presentation, lilies usually have 3 petals, buttercups have 5 petals, corn marigolds have 13 petals, while black-eyed Susans commonly have 21 petals. Notice that all of these numbers belong to the Fibonacci sequence.
A flower is related to the Fibonacci sequence because many flowers have a numbers of petals that matches the Fibonacci numbers, such as 3, 5, 8, 13, and 21. This flower is related to the Fibonacci sequence because its petal grows in a spiral pattern that closely resembles the Fibonacci spiral. This spiral pattern is closely related to Fibonacci sequence and the golden ratio, which are common patterns in our nature.
You may wonder, does every Sampaguita always have exactly 5 petals? Not always. Sometimes, nature creates small variations. However, the most common flower structure contains 5 petals. So, why does nature prefer these numbers? Scientists believe this arrangement helps flowers grow more efficiently. The petals are evenly distributed around the center of the flower. Because of this arrangement, the flower can receive more sunlight and becomes easier for bees, butterflies, and other pollinators to reach. This means the Fibonacci pattern isn't simply making flowers beautiful. It also helps them survive. That's what makes mathematics amazing. A simple number sequence can explain something as beautiful as our national flower. Now that we've discovered Fibonacci in flowers, let's head to our next location and see how other objects also follow this incredible mathematical pattern.
Our nature. The way the petals grow, it creates in a natural spiral that helps the flower use space efficiently and bloom beautifully.
This sequence was introduced by Leonardo Pisano, better known as Fibonacci, in his famous book, The Book of Calculating. Although the sequence is simple, it appears surprisingly often in nature. Scientists discovered that many plants and flowers grow according to this pattern because it allows them to use space, sunlight, and nutrients more efficiently.
Apart from the flowers that my friends mentioned earlier, we can find some Fibonacci numbers too on some leaves. When it comes to the flowers, you can see the Fibonacci numbers on their petals directly, right? But when it comes to the leaves, do you wonder how? Well, when it comes to the leaves, you can see or you can find the Fibonacci numbers right in their veins or in their trunks. But take note, not all the Fibonacci numbers can just be only found on one specific or two specific places, which is their veins or their trunks. They can be found also on their quantity on a single trunk or a single branch, just like this one.
Another example is an apple. What happens when we cut it horizontally? Look closely. What shape do you notice? We see a five-pointed star formed by the seed chambers. And once again, the number 5 belongs to the Fibonacci sequence. This arrangement isn't only beautiful, it also protects the seed and distributes them evenly inside the fruit. Today, we've learned that mathematics is much more than numbers written on a board. Nature itself follows mathematical principles. Through the examples we've shown,
A flower is
we've discovered that Fibonacci numbers help explain many natural patterns. These patterns allow plants and fruits to grow efficiently while creating the beauty we surround us. The next time you see these objects, take a closer look. discover that mathematics has been there all along. Thank you for watching. We hope you enjoy our educational vlog. Till next time,